Alright, compared to Review 6, Review 7 is going to be pretty short and sweet. Just reviewing the structure, the periodic table. You really need to make sure you focus on the alkali metals, the alkaline earth metals, the transition metals, your halogens, and your noble gases. Also, just please remember that periods run left to right, and that groups or families move from top to bottom vertically. So your your alkaline metals are members of group 1. They are your most reactive metals. That's why we often find a lot of them stored under oil or kerosene. They are really soft. They can be cut with a knife. They will reoxidize very quickly, so that's why we want to make sure that we keep them stored away from the air. They react very, very well with water and acids. And when they react with water, they undergo a single replacement reaction. So they make hydrogen gas and a metal hydroxide and give off a fair amount of heat. They also are positive 1 ions. That's something you want to make sure that you know, that the alkali metals form +1 ions. That's the only charge you're going to see, since they only have that one extra electron, the one valence electron. And that's all they need to go back to have the electron configuration of a noble gas. Your alkaline earth metals are +2 ions. They are members of group 2. They are reactive, but not as reactive as the alkali metals. They will lose 2 electrons to become like the noble gases. So beryllium, magnesium, calcium, strontium, barium, and radium are going to be +2 ions. Again, that's something you want to make sure that you're familiar with, as well as the general location of the alkaline earth metals. One last thing before I go backwards. Make sure you notice that hydrogen is not highlighted in green with the alkali metals. Hydrogen is definitely not an alkali metal. Our transition metals are in that middle section of the periodic table, the D sublevel. They tend to form colored solutions, especially the ones that have multiple oxidation states. I'm going to point out on your summer letter there were several transition metals I asked you to learn the oxidation states of. I'm not making you learn all of them, but there are definitely some common ones you need to be familiar with. These are the ones that we tend to see more in jewelry, silverware, and coins because they're a little more stable. They're further away from francium, and so they are able to not undergo oxidation as readily as what we see with like the alkali and alkaline earth metals. The halogens, again, one group away from the noble gases. Fluorine, chlorine, bromine, and iodine, these are our diatomics, the Brinkelhoff elements. They are the most reactive nonmetals, and because they have 7 valence electrons, they only have to gain 1 to become like the noble gases, and so they tend to form -1 ions, especially in ionic compounds, and that is a charge you need to be familiar with. And then finally, we have the noble gases, with the exception of helium, which has 2 valence electrons. All of these have 8. They are completely stable. They have filled outermost energy levels for their electrons, so they do not typically react. There are some, as always, there are some scenarios where you can get them to react with extremely reactive nonmetals like fluorine, but they typically are going to be inert. They are monatomic, and they just kind of hang out and watch everybody else fight for their electrons. So I told you I was going to point out something in your summer letter, so let me go do that real quick. So this should help you answer questions 21, A through E. But in terms of your summer letter, what I wanted to make sure I pointed out, we're going to get back there, sorry. Here it says a transition in the heavier elements. If you notice, there's a few of these on here that have multiple charges: chromium, manganese, copper, iron, lead, nickel, tin, silver, and zinc. You really want to make sure that you know those charges for those specific metals. Mercury was only listed once over here, but that's because it's also listed over here as a polyatomic cation. I would really encourage you to make flashcards for these. That's going to make your life a lot easier. Silver and zinc did not have multiple charges, so that's why you don't see them listed with the Roman numerals, but you do need to know those 2 oxidation states. Again, up here you see group 1 being the +1s, group 2 being the +2s, We didn't talk about group 13, but it is a +3 ion. Group 17, the halogens being the -1s, and if hydrogen's acting as an anion, it too would be -1. Group 16, we didn't emphasize a whole lot in terms of the characteristics, but they would be -2s, and then group 15s would be -3s. We're going to spend more time on that in the next video, but I just figured I'd go ahead and point that out now while I had y'all. Okay.